All right. So we're going to go over the goals. Sorry, I got interrupted. I was talking to a teacher. So this is the rest of what we did for the lesson, talking about percent of increase or decrease, looking for the original amount. And my pen's not working. Pen. No pen. Oh, that's working. My actual pen must be dead. All right, great. So you guys going to get some really nice writing if my pen's dead. That's fantastic. Bear with me for a second. Real life problems right here. See if I can plug it in, which you can't see. You're just listening to. You know how it goes. This is my life. Let's see what we got here. Maybe if I plug it in, it'll work. You'll find out in a moment. So plug it in. Lights on. Still doesn't work. Still doesn't work. That works. That doesn't work. Maybe if I lay it down. Still doesn't work. Okay, well, I guess it doesn't work. Okay. So increase, add to 100, decrease, subtract from 100. Okay. So we're going to be looking at part of algebra, kind of. So the gas tank in Dad's car holds 12 gallons. Okay. The gas tank in Mom's car holds 50% more than that. How much tank does the tank hold? So we're looking for the total amount that the tank holds. Okay. So that is going to be a percent increase. So we are going to have our 100%, whatever that is, plus the 50%, right? Well, our 100% is 12, and we're looking for the 50%. Well, total, that is 150%. So we can percent to decimal and get a 1.5 there. So our original is the X. We don't know what it holds. Our original is the 12. And we're looking for our total after, which would be 150% more. So 1.5 times 12. Okay. You can do it two different ways. If you can't remember what the decimal is, if you don't know what the decimal is, or if you don't understand, you can do your 100%, and then 50% of that would be 6. So then 150% is going to be 15 gallons. So if they asked for how much more it is, that's your 50%. What they're asking for is how much does Mom's tank hold? That's your Y here. Okay, so that's going to be that 15 gallons. Okay. Number 2. A school had 1,200 students. Oops, sorry, let me clear that out. Clear screen. A school had 1,200 students last year and only 1,080 students this year. What was the percent decrease of the students? Now, we do not know what the percent is. We know the original. We know the end result. Okay, so now there's two ways that you could do this. You could figure out what the percent decrease was out of from the 100 to get what your decimal is, but we're going to look for how much it has decreased. I really wish I could use my pen because it's kind of frustrating that it's not working. Okay, so you can do two options. Find the difference or subtract after. So if I subtract after, I'm going to do it both ways. If I subtract after, I'm going to have, that's our end. That's how many students were after the decrease. Times something. We don't know. We don't know our percent. We're going to multiply that by our original amount, right? Now, when you solve for a variable, okay, you divide. Okay, and we're going to get K is 0.9. Now, that means that this amount right here is 90% of the original. It did not decrease 90%. It's 90% of the original amount, right? So if that's 90% of the original amount, the decrease is 10%. Okay? Now, if you do it before, you can subtract the total amount of students, the original, minus the new, which is 120 students. And so then what percent out of the original is that? Because this is my decrease, and that would be 10% or 0.1. Okay? Two different ways. It's going to take us some time and practice to go through this. Next one. Okay. 1 week, gas was $1.25 a gallon. The next week is $1.50 a gallon. At what percent did the price increase? Same thing. We can do our $1.50 is equal to what times $1.25, right? And then when we divide, I don't remember what it is. I'll have to look it up. Okay. So we get 1.2 equals K. Now it didn't increase by 120%. The 100% represents the original. This represents the increase. This is the original. This is the increase. So it's a 20% increase, right? If I go the other direction, if I take the $1.50, that's my new, minus what it was, I get a 25-cent increase. If I want to know what percent of the original that is, it is 20%. Okay? Two different things. All right, number 5. After a 25% discount, the price of a shirt was $12. What was the price before the discount? So I want to know what my original price was. I don't want to know. So you're trying to figure out what percent of the price did you pay? Okay, what did I pay? So you paid 75%. So $12 is my new. 75% is what I paid times my original price. Right? Because if I have my original price minus my discount, that's what I paid. Okay, right. So I paid $12. My original price was something we don't know, right? And my discount was that 25%. Okay? So I'm going to divide. I get x equals 15. So 15 is my original price. My discount is $3. I paid $12. Okay? Last one. Compared to last year, the population of Boontown has increased 25%. The population is now 6,600. What was the population last year? Okay, so if it increased 25%, that would be 1.25 times the original is going to equal your population now. Because 100%, which we don't know, plus the 25% is going to equal what our new one is. What our new one is. Oops. I don't even know how to reverse. 125%. Okay. So I'm going to divide. And let me calculate here quick. Oh, geez, I put the wrong number. That would help. I get 5,280. So 5,280 was the original. 25% of that is 1,320, and that should equal my new, right? Because it's a percent increase, which is why we multiply it by this. Okay? If you're confused, don't worry. It will get easier the more that you do it.